All right, in this problem, we're looking at a hydrate. So this is how we would run our hydrate lab. We would find the mass of the crucible, we would find the mass of the hydrate and the crucible. We would heat that, wait for all of the water to evaporate off, and then we would be left with the anhydrous. So remember, anhydrous means without water. Then we can look at the numbers and we can solve for the formula, and then we can name this hydrate. So to find the mass of the barium hydrate, we have to subtract out the crucible. So we would take the mass of the crucible and the hydrate, 20.04, and we would subtract the mass of the crucible, which was 15.91, and we get a mass of 4.13 grams. Then to find the mass of the barium chloride anhydrous, remember, which means without the water, we would take the mass with the crucible, subtract the mass of the crucible, and we're left with a mass of 3.52 grams. So you're subtracting out the crucible, really. Then to find the water, you subtract the hydrate and the anhydrous, because remember, when you heat it, the water evaporates out. So the difference in the mass is the mass of the water. So we would say 4.13 grams minus our 3.25 grams, and our mass of water that evaporated off was 0.61 grams. Now we need to find the formula, and we do it the same way that we find all of our empirical formulas. We're going to take the masses and we're going to convert them to moles. There's two parts to a hydrate, right? You have the ionic compound, dot, and then you have the water. So we need the mass of the ionic compound, find moles. We need the mass of the water, find moles, and then we can get the ratio of the two of them. The ionic compound then, without the water, is the anhydrous. So we want the mass of the anhydrous barium chloride. Barium is in group 2. So it's +2. Chlorine is in group 17, so it's -1. So when you cross your charges, it's BaCl2. So we take that 3.52 grams, and we're going to convert that to moles. So we put grams on the bottom, mole on the top, 1 mole, and then we find the molar mass. So barium plus 2 chlorines has a mass of 208.28 grams. And that gives us, if we keep the same number of significant figures, 0.0169 moles. We're going to do the same thing for the other half of the formula, which is water. So we take the mass of water, 0.61, and we convert it to moles. So the mass of water, 2 hydrogens plus an oxygen, and then that's 1 mole of water. Multiply and divide, and we get 0.0339 moles of water. Once we have our moles, then we divide by the smallest. For hydrates, the smallest should always be the ionic compound. So that's a way to check to make sure that you've done your math correctly up to this point, is that the ionic compound should always be the smallest amount. So we have 1 BaCl2 to every 2 waters. So the formula then would be BaCl2 dot 2 H2O. For every 1 barium chloride, you have 2 waters attached. To name this, we would say barium chloride, using our ionic naming rules, and then we have 2 waters. So the prefix for 2 is di, and then water is hydrate. So this is barium chloride dihydrate.